All right. Good morning, good afternoon, good evening, or depending on your time and your location. I'm Engineer Moses Unuafe. Today, I want us to talk about the topic, Hazardous Area Awareness Workshop. On this topic is going to be splintered into different sections for better understanding. I encourage viewers to watch out for each of these sections for us to have a proper understanding with regards to hazardous area classification, hazardous area awareness, equipment classification, ignition source control, and other more. As you all know, as global demand of electrical device and equipment continue to surge in drive by execution of increasingly complex tasks in large scales of industry projects, imperative to prioritize the safety has never been more critical in an environment where flammable gas, vapor, mist, or combustible dust are present. The risk of ignition and explosion poses a serious threat to both personnel and infrastructure. So to ensure the safe, successful deployment of electrical equipment in such hazardous area, it is essential to adopt a rigorous safety standard, proper classification of protocol, and critical protective technologies. This includes understanding the nature of explosion atmosphere, selecting the equipment rated for specific zone and gas dust group in implementing robust monitoring and maintenance practice. Why do we have to do this? By integrating this safety into various phases, from design, installation, to operation and inspection, organization can mitigate risk, comply with international standards, and safeguard life while operational efficiency is ongoing. So therefore, hazardous area awareness is referred to understanding and recognizing the environmental where flammable gas, vapor, mist, or combustible dust may be present in quantities that ignite or explode. This area requires special precaution, equipment, and procedure to ensure safety and compliance. And there is a need for us to understand what is hazardous area. So hazardous area is where an explosive atmosphere is expected to occur in quantities such as to require a special precaution, construction, installation, and electrical apparatus for against what? Source of what? Ignition. Having known this hazardous area, we can also know a non-hazardous area. So what is a non-hazardous area? This is an area where explosive atmosphere is not expected to occur in quantity, such as to require a special precaution for the construction, installation, and the use of electrical apparatus. Now, for an explosion to occur, it must meet up with three elements, which are regarded as conditions. And these conditions are a flammable substance, which can be dust, mist, or vapor, or a source of ignition, which can be heat or spark. And the last, which is oxygen. For now, the basic principle of explosion protection is therefore the avoidance of this common occurrence of this condition, which I regard as an element. Now, we have to study these very particular three elements, which are regarded as condition, properly and know how to eliminate it. The first element, which is regarded as heat, initiates a combustion process by raising the temperature of the fuel. And what is the source? The source is to open a flame in electrical spark or friction or hot surface. Now, how can we eliminate this? We can eliminate this by removing the heat using a water or fire retardant like foam. One other source, which are regarded as condition or element, is fuel. It's the materials that burn wood, paper, gasoline, oil, fabrics. And these fuel have different flash points. The minimum temperature of ignition is regarded as what? A flash point. So how do we eliminate this? This can be eliminated by safe storage. The last element, which are regarded as condition, is oxygen. It combines with fuel to release heat and light. So in most cases, most atmospheric of oxygen of 25% excite what? Fire. That is where what? Fires thrive. Now, how do we eliminate this very particular oxygen? This oxygen can be eliminated by smootering. Take, for instance, by fire blanket, CO2 extinguisher. And this must only be used by aiming this extinguisher at the base of the fire while considering the wind direction. I want you to understand that a hazardous area awareness also consists of these two elements, which are regarded as element 2. These are the dust and the gas. And this dust, flammable gas, and combustion dust can create explosive atmosphere when mixed with air in certain concentration. Though they behave differently, they share a common threat of ignition or explosion. Take, for instance, the dust, which is regarded as the oxygen, the flammable substance, the source of ignitions, and also the gas. This gas is an explosive mixture. So a mixture of a flammable gas are vapor or air, where after ignition, combustion, or propagation through the unconsumed and mixture without the additional supply of energy. Now, there is a need for us to know the lower explosive limit of each gas and the upper explosive limit of this gas, as the case may be, respectively. Now, for instance, a lower explosive limit is a concentration of a flammable gas or vapor within which the gas became explosive. Now, for example, methane, which is 1 atom of carbon, 4 atoms of oxygen, is 5% by volume in air. If methane concentration is below 5%, it won't ignite, even if you expose it to what? To spark or flame. Having known this, that is to say, it is very clear to us that a lower explosive limit is the minimum concentration of a flammable gas or vapor in air required to ignite in the presence of what? Source of ignition. Now, if we are aware of the lower explosive limit, then what is the upper explosive limit? The upper explosive limit is regarded as the concentration of gas or vapor in air, below which the gas atmosphere is not what? Explosive. Take, for instance, for example, propane. Propane upper explosive limit is 9.5% by volume in air. Now, if a propane concentration exceed 9.5%, it won't ignite because there is no enough oxygen to support what? Combustion. And I want you to understand that An upper explosive limit is the maximum concentration of a flammable gas or vapor in air, above which the combustion cannot occur at the point the mixture is too rich in air or lack enough oxygen for explosion. So we can't do without letting us understanding what it means by flash point. So the flash point of a liquid or product is the lowest temperature at which the surface of the liquid emits a sufficient vapor to be ignited by a small flame or spark. So having known this, there is also an auto-ignition temperature in gas. This auto-ignition temperature is approximately 280 degrees to 470 degrees. So take for instance, for an example, if a gasoline vapor accumulates near a hot surface, let's say for instance, at this scenario, let's use a car, an overheated engine block in a car or exhaust manifold. At the surface reaches around 2,800 degrees, the vapor can what? Ignite spontaneously without any source of what? Ignition. So therefore, an auto-ignition occurs when a substance reaches an auto-ignition temperature, the minimum temperature at which it is spontaneously ignited without any external ignition or source of ignition, regarded as what? Flame. I encourage viewers to watch out for the second section of this aforementioned topic with regard to hazardous area zoning. I want you to share this video so that others can gain knowledge. One love. Thank you.